By the end of this video, you will have an understanding of what an event system is, why we use it, and how to implement the class in Unity using C#. For the best tips and tricks on game programming and game development, don't forget to subscribe to my channel and hit the bell icon to be notified when I upload new videos every Monday. My name is George Wulfers and I am a professional game developer. Let me help you on your game development journey. And don't forget to watch to the end. Step number 1. What is it? In order for us to understand what an event manager is, we have to look at where it comes from. In software development, we have design patterns. And one of the design patterns used in event systems often is the observer pattern. The observer pattern is an object. It's usually called the subject. And this subject holds a list of dependents. And these dependents are oftentimes referred to as observers because they're observing the sender or the subject. This observer pattern or this observer object notifies the list of dependents of whenever a state change happens within the program, usually by calling one of their methods. And through this, we can actually implement a system that sends messages based on events to other objects. Step number 2. Why do we care? So the reason that we care about this, oftentimes when we learn how to program, in order for us to be able to call a function or to tell an object that something happened, we have to have references to those objects. Many times these connections can prevent modularity within a program, meaning that once you take out a single object that depends on a physical connection with another object, everything falls apart. And oftentimes, even these objects, these systems, you don't need to have this, I guess, finite connection between them because they don't really need to know about these other objects. And having an event system will make a lot of things very, very easy for you, like communication between objects, sending data between objects. Most of the time when we make games, we tend to tell all of these different objects to point at this central object and vice versa, creating a very confusing data flow in your programs, and everything becomes super dependent on everything else. It's not modular, and if something goes down, everything breaks. And another big point of having an event system like this is we don't have to, if we want to tell an object that something happened, for example, if we want to tell something that it needs to play a sound every time something happens, we don't always have to rely on the update loop for games, because this, if you have so many things constantly checking and updating every frame of the application, everything becomes, depending on the size of your application, it can really slow things down. And one way to minimize the CPU usage is to have those events in place so that you can, whenever needed, you broadcast a message to let something know that it needs to do something. So let me know in the comments below if you're struggling with anything and if everything is making sense. Step number 3. Implementing the class.
Okay, so with Unity open, let's go to Scripts Foundations and let's create a new C# script here. Let's call it Event Manager and let's open that up. All right, so we're going to be, okay, so that was a lot, right? So let's now explain what we just typed here. The first thing we have to know is, well, you don't really have to worry about that, but this is just telling the compiler what we need to include. These are the header files, packages, or whatever you want to call them. Actually, these to be able to actually use whatever we need to use in order for us to make what we need to make. This is just the namespace that we want for this class. It's still in the foundations folder and it's inside of the events category because this is just manages events. So then we create a class called Event Manager. This manager class, as we saw in the previous episode, should be a mono singleton because if we had multiple classes of the same class, we could potentially run into problems as well when there's multiple classes. So we only need really just this one class to manage everything that it needs to manage, such as telling objects what to do, pretty much, when somebody requests an event to happen or triggers an event. Okay, so let's dive into how we actually do this. So we need a dictionary. If you don't know what a dictionary is similar to a list, but it's more than a list because as you can see, it has two parameters here. So this is known as key type pairs, which this is the key that allows us to be able to look inside, um, to be able to search to look into this list with a specific key. In this case, it's the name of the event. So and then this is just the delegate, which is, if you don't know what a delegate is just a function pointer that we can pass around and call whenever or wherever we want. And the cool thing about this, it also contains a list within itself. So this is pretty much a list. Um, each category or each event name is going to hold a list of functions can um, that it can use. So we're just going to call it event list, and that's how we initialize it. It's going to be private because we don't really need to get it from anywhere else since we're going to be using the functions that we created in order for us to interface with this thing. So this is the declaration. It needs to be public of what a delegate means in this class. So we have to tell it, okay, what is the signature of the functions that we care about for our system? And they all will have one parameter. Um, and we're just going to pass that. This is just going to be the pretty much the blueprint of every function that needs to be used in this system. This is how it needs to go. It can only have one type, and that can be anything. Okay, and we'll actually look at this later on how to actually use it to actually make sure that it is running properly. So then we just need to override this. We don't, since there's not really going to be much here, we don't really need to override it because it's just the base functionality, which it just, if I remember correctly, it just initializes this to be true. Is initialized to be true. Okay, so we don't really need to override this here. Because we're not making any changes. If you were to make changes, then you could have it there, but we don't need to. So then we also override this property, stay alive. And we only need a getter here. We only need to change the header of the getter, not the header. And we just need to return true for it. Because in the previous one, if we go to peak, actually, is this thinking that it's just a whole new thing? Maybe. Let me go to mono singleton real quick and let's see what we said here. Okay, so let's just do that and let's just do a modification here. So we're just gonna say that it's gonna return false here, right? And we don't need this there since we're just doing that. Um, so that's gonna be that modification and and let's see. Let's just make it do that. And let's see. I'm not sure if it's supposed to still, be linked to the other one. Yeah, I don't think you can have that here. Anyway, so yeah, this is just overriding the this mono singleton one, which instead of saying that we're going to return false, we're just going to return true. And we can actually check that whenever we test this class. So let's get to the meat of it. Okay, so the first function that we have is just going to be a register event function. We're just going to pass in the string of whatever we want the event name to be. This could be on player death, on play sound, or on player play sound, or on mouse click, or something similar to those lines. We're just going to register that, which we're just going to make sure that there's nothing with the same name in here. And usually with hash tables, there shouldn't be any duplicates because they should all go into the same one. But we're just guarding against that if that's not true in this case, so that we don't need to do anything here. So yeah, we're just asking the event list to see if it contains the event, and if it doesn't, then we're just going to add it. And the actual delegate, the function that we need, we're just going to pass a null because we don't have any information for that. We are going to, the next function is going to be kind of like it's a check to let us know if this event is actually registered, meaning that it's in the event list already. So we just return, the if this contains key function returns true, then that's gonna tell us, okay, yes, it is registered. And if it's false, then we know that it's not there. So that's how that works. Then to remove an event, we just check if it exists, and if it does, we just remove it from that list. And then this one, the add event callback, this one allows us to actually uh, register the actual function with whatever type we want it to be. So we pass in the event name that we want this function to be paired with. And the first thing that we need to check is if it actually exists. So we don't want to have we want the system to be kind of like forgiving to the user if they forget to call register event. We're not going to be like, oh no, you first have to do that no matter what. We're just going to be like, no, if they forgot to actually call register event, we're just going to call it for them if 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 it is not registered yet. And then they can actually do that because it would be kind of sucky if they would have to, do 10 million steps just to add a single function to the list. So whenever you're working with systems, you want to allow flexibility and ease of use to your users. Okay. So the next one is remove event listener, which since we called event callback up there, we're just gonna call it callback as well, since it's just called callback in this one. So as this is also gonna take the function prototype and the event name that it's paired with it. And if we do not have an event here, if it's not registered, then we're gonna be like, okay, we don't need to do anything, we don't need to remove anything, so we just return. But if it does, then we're going to be here and we're pretty much just going to subtract it. I know these lines look kind of weird, but essentially what we're doing is that we are pretty much since so when you add delegates to each other, um, this is how you add them with a plus sign. Um, and we have to make sure that we cast it to whatever our prototype of that function is, which is our event callback, which we registered up here. We got to make sure that it follows that signature, if you want to call it that, um, for it to work. I believe if you don't add this, it's just going to be like, this is incompatible. As you can see, it says operator minus cannot be applied of type delegate and event callback T. So we actually have to cast this one, the delegate, onto whatever we want it to be stored in that list. And if we get to the point where this event is just null after we remove something, because remember when we call register event, there is a slot for one of these, but it's null. So yeah, if we do eventually find the null one, then we're just going to remove that event completely, which just removes it from the list. And that's it. Um, and then the next function here is going to return a Boolean. This is to check if the actual callback, let's call it a callback now listener, which can be, it's the listener, it listens for an event and then it triggers that event. But I like calling them callbacks because it calls back to that function that you register, whatever. It's just your preference. You can call it whatever you want. So it also takes in the t for the template of whatever type you want. And also you have to pass in the function prototype or signature of your event that you want to, that is associated with the event name. So if we're false here, we're just going to return, and that's it, because we don't have anything. We're just going to return false, essentially. Um, and to be honest, I don't really like that we have these two things here calling result. When I write my functions, I like only one place to return, so that, and actually we can just say only if it's true, then we call this in here, and which we'll get to in a bit, and then we'll return here at the end of that function. The reason why I like doing this, only having, whenever I can, only having one point of exit for that function, is so that it makes it easier for us to, there's only one branch it can branch out of, right? Instead of having multiple ones, you only have to check, essentially, you only have to check for one point of exit, which makes debugging and everything much easier than if you had multiple returns, all across, all scattered across your function. Then you would have a harder time when it comes to um, debugging and seeing what issues you have within this function. So just a pointer there. Okay, so in order for us to actually check to see if a certain callback is registered in this event list, we need to first have it. So it needs to be registered. So if it's true, we're going to go in here. And like I said before, delegate is a list, right? So it's pretty much an array. So we're going to pretty much get it from the from here, from the event list. We're just going to get, it's called invocation list because when you call it, you invoke it, right? So we're just going to get it, and this is pretty much what we get. It's just a array of delegates, and we're just going to do a for each loop go through each element in the list, which we're going to be calling D. Now, we also note here that if we were to just do this, it's going to give us, it's like possible unidentified reference comparison, meaning that the signature for this callback is event callback, and the signature for D is actually a delegate. So it's going to complain. So you have to cast it. Make sure to cast it to whatever you are comparing it to, which is our event callback that we registered up here. So yeah, so if these two signatures match, and remember, if you don't know how this works, it's because each function is a pointer. And yes, I know that in C Sharp, you don't really see us working with pointers, but in the background, it is always a pointer. When it compiles and it actually runs the actual code, it actually works with pointers. It just, in C Sharp, it doesn't allow you to, you don't see that difference. But if you were working with C++, then you'd see that it is actually the the actual function. It's actually a function pointer, which points to the memory location in memory. And if it has that same signature and it has that same memory location, that address, then it's going to be like, okay, these two are the same. Okay, so then we're going to say, okay, result is going to be true, and then we're going to break out of this loop because we don't need to search anymore. We already found what we wanted to find. So we exit and we just return result, and it's either going to be true or false. if it's there or not. So that's how that works. All right, for the last function, this is a pretty easy function. It's just allowing us to actually pass the value or the data that we want to have.
Step number 4, testing.
Let's create a demo folder here, and we're just going to create two classes. And the first one is going to be, let's call it test, event test, and then we're gonna make another one. Oh, not a folder. C# script. I don't know, event caller, I guess, or something. I don't know. And we're gonna open these two, and let's work on the event caller because that one is the easiest one. Okay, so for this one, we're pretty much just gonna have this call event data, and we're just gonna here make sure that we have an event manager that exists, and that we have an event registered called on test event callback, and we're just gonna raise that event and pass in that data from here. Pretty much we're gonna be using this within a button, and that's that. Onto the event test. Okay, so pretty much what's going to happen is in the start, whenever that gets called, we're going to, if this event is not registered yet, then we're going to make sure that it gets registered here, or it gets added to the event callback list for that specific event name. And we're going to pass in this function as the event callback, okay? And whenever it gets triggered by the other class, this is what we're gonna see. Make sure that the event name matches on both sides, on where it's being called and where it's being registered and unregistered. Um, Pretty much whenever we destroy something, we want to make sure we unregister ourselves or remove ourselves from that list. And it's pretty much the same, but in reverse. So we check to see if it's registered, make sure it is. And if it is, then we remove it. And here we do the opposite. If it is not, then we add it. And that's pretty much how it works. Now let's go to Unity and build it up. So we're going to create a scene. We're going to call it Event Manager Demo. And in here, we're just going to make a simple UI. We are just going to have a button, and that's all we need. Okay, so make sure that we're going to be using this eventually, so make sure that we import into this project our Text Mesh Pro. We don't need the extras or the examples here. But what we do need here is we just need to name this We're gonna name it, what do we want to name it? Race event or something like that. We're gonna make sure it is centered. We're gonna make sure that this guy is not like that, and that we have auto size, and that's pretty much it. So now we need two empty game objects. We can call one event test, and we can call the other event caller, and just put in the scripts in there, and in the button here where we have on click, we're gonna add the color into the object slot, and we're gonna go into event caller and make sure that we do call event, and we're just gonna type in here the message that we want to type, which is going to be this is our event system working, right? So then let's press play, and actually instead of having maximize, let's make sure it's not maximized, and let's make sure that we're only seeing errors, and when we click it we say we get this message, and it says event triggered from event test data. This is our event system working. Okay, so now we know that it's working properly. Okay, so let's do that, and then let's just delete event test. Save that, and let's do it again. So now press the raise button, and as you can see, we deleted that object that was registering into the event system that we have, and when we deleted it, it broke the connection, but it didn't break the program. This is very, very important, because now we can have modularity and still have the advantage of the benefits of having different systems talking to each other or sending messages to each other, but it doesn't break the program. If I mean, it technically will if you don't make it do what it needs to do, but it will not crash. You won't see that crash, which it can be a good thing and a bad thing, because it'll be a good thing because now players will be able to play the game no matter what, to a certain extent. If you have systems that are required to actually play the game, then they'll just sit there probably in a blank screen or something. But you may not always know that you're missing something or something is not working properly because it doesn't show. So that's when, you know, debugging really comes into play, and just making sure that you go through everything and you test it and test it. But overall, I think event systems are very, very useful.
Congratulations! Now you know what an event system is, why we use it, and how to implement it in Unity using C#. If you would like to follow along, I have provided the link to our project in the description below. And don't forget, go to our Facebook page. Send us a message. We want to hear from you. Before you go, check out these videos next on how to make a 2D game using Unity. And if you like this video, hit that like button. Be sure to subscribe and share this with your friends. Thanks for watching. Have a great day, be safe, and have a great week. I'll see you next week.